Hi, this is Stan. Welcome back to the Crow's Nest Railroad. Did you forget about the Chloe? Well, we haven't. Stay tuned. Well, Bob, this is pretty exciting. For those of you that are regulars, you recognize Bob, but if you're new to the channel, this is Bob Rapperstraw, and he's got a workshop here, a machine shop, and he's built 2 steam locomotives himself. He's restoring this Chloe locomotive, and it is just looking fantastic. And also, if you've seen any recent videos on the channel, you know that Bob is heading up a rebuild project on an American 440 15-inch gauge. That's not our topic today, but this is Bob, and I can't believe I haven't seen the Chloe this put together. This is fantastic.
Hi folks, Stan, well, don't get too excited because the cab isn't in the final position at this point. But what we're going to talk about today will be 2 aspects of steam locomotives that you probably don't think about. One of which is going to be the bracketing required to hold the copper tube piping that we utilize on our locomotives. And the other will be the forming of that copper tube in the correct shape that meets the requirements to hit both endpoints of the tube connection for you. So we're going to start with the fabrication through a die of the clamp for those pipe hangers, and then we'll move to the actual forming of the copper tube itself.
All right, so let's hop over on your side of the locomotive and take a look.
All right, what we've got here once again is this bracketing that we need to provide for all the piping on a locomotive. Now in this instance we're not going to talk about this particular bracket here, which is a machined piece. I want you to more focus on this little clamp mechanism here. So we have a simple L bracket under the floor of the cab, and then we have this somewhat more complex formed curved piece that you see right here that kind of looks silvery. And we're going to show you how we form that with a die and the hydraulic press. Alright, what we're going to show you here is a simple die. That's what you see here. Now we're going to ignore those bumps because they're used to press down in a smaller diameter pipe in a similar die to this. But now we're talking about a 5/16 diameter copper tube. So we're going to pretend like I have a flat plate of stock here, just a thin 34, 40 thousandths thick, and pretend it's lying across here like this. We're going to go to the press and we're going to push this down with the press ram, and it's going to form this shape. When you get it down in that die, it fits perfectly, and this then at the end of the stroke of the die, it is flat across there. Then I use a little piece here to just make sure that those 90-degree bends are fully flattened at those 2 points. But when the ram comes down, it pretty much flattens those out, as you'll see. This is just an extra touch just to make the corners right here a sharp 90. So we're going to show you that here next. Alright, so what we've got is a small abrasive cutoff saw. Now you guys know about Harbor Freight because I'm sure you've all got one of these bigger abrasive saws. But for small work, I ran across one from Coastal Precision Tools. Now this is actually used to cut copper multi-strand cables for the communications industry, but this is the guy that makes this small abrasive cutoff, and it is really handy, as I will demonstrate. We've set the length of the part up, and we'll put a stop here that's been a modification to their original tool. So this is something I made just so I could get repeated cuts. We're going to stick this guy in here all the way to the end where it marks up against that, and we're going to tighten the clamp. And if we did our homework right, and we put this guy on here to grab that when it cuts loose, we'll be able to cut it. Pretty slick. Now that would have been a whole lot messier with the larger, wider blade on the Harbor Freight unit. This is a very narrow blade, about a 1/16 of an inch, not even that much. So it makes a nice clean cut, and it is the most used tool I have for all my piping work. The copper tubes are cut, the brass pipe is cut with this, the whole enchilada is made, and it's very versatile because it angles as well. So I highly recommend the tool, but I thought if you didn't know where to find it, the Coastal Precision Tools guys still sell these guys. Alright, let's go over to the sander, and we're going to trim this a little burr free, and then we'll put it in the die. Alright, so now we've positioned the die and the strip of material in the press. I'm going to position this by hand, just eyeballing it over the hole, because it'll find its own way when the time comes to put it in place. Alright, now we're at the part where we're pressing down. I want you to watch that closely as it finds its way. And you can see the ram is all the way down and has it flat. So now we're going to raise the ram, holding on to this, put our 90-degree corner piece in there, and just one more come down. Just make that tight, and off it comes. This comes out.
Wow, it just is like quick.
Just like that. Of course, it took me an hour to make the die. Alright, so next we're going to go ahead and we're going to make a sweeping bend, a 90-degree bend, kind of like this, in this copper tube, to connect to this brazed on fitting. So here we are, it angled slightly, so this tube end is going to have to fit just inside that with a nice 90-degree bend over the top of the overflow on the injector. So we're going to show you how we do that. This distance is about 3.5 inches. So I'm going to get a tubing bender. I'm going to come down 3.5 inches, and I'm going to make that sweeping bend. Now I've made it a little longer, so I will ultimately trim that to the right height, because this distance has to match this mounting point as it sweeps around and comes straight up into this fitting here. These are tubing benders for copper or stainless steel tubing. We have two different sizes here. We have a small size for 3/16 and 1/4 inch, and it won't go up to the size of our 5/16 copper tube. For that we need the slightly more involved bender, which has the benefit of having some angled protractor measurements on the side. So we're going to put that in here, and we know that we want that to be 3 inches straight before the bend begins. So we want to put this right in there. Now these are grooved to allow the right size pipe. So we go, in this case, 5/16 in the middle, 1/4 inch in the outboard side, and 3/8 copper on the other side of that. So I'm taking the middle road here. We're going to put that in, and if you look at this bar, that's where the measurement, the straight part starts. Now that being said, it actually straights a little bit further, but we're not going to worry about that. We don't care if it's a little long by 1/16 of an inch. It will be trimmed off in the end. So at this point I'm setting it up here, my line's on that board, and then we're just going to go ahead and wrap this around 90 degrees until these protractors show us at 90. And we are there. And that constitutes the bend with this kind of tubing bender.
Do you put any lubrication on that, or just slips around the pipe?
I do not put any lubrication on that. Now here's the other issue. Now that we've made this bend, this tubing is rock hard. So if I want to make another bend, I have to anneal it easily.
So the beauty of this tool is that it doesn't pinch, and so you've got the same interior inside diameter all the way through that bend.
Stan, that's exactly a good point, and I should have mentioned that the reason you're using the benders, and you'll see that this is a half groove slot there, that it contours that tube on the lower half, and the grooves in the top of this tool allow me to come around and sweep that around and it contours the top. There is no buckling. If you don't do this with the bender, you get a narrowing of this copper tube, which is one more restriction that you add to the restrictions of all those brass pipes and the elbows and everything else. So let's try and make the flow as easy as possible, and a simple sweep like this should do the trick. So that being the case, let's go see how it fits. Alright folks, so we're getting ready to braze this fitting that I fabricated on my lathe to fit on that copper tube. We're going to put a braze joint there because it's subject to some mechanical strain, and the soft solder is okay, but wouldn't be my first choice in that application. So we're going to take this off, and I'm going to show you how we go about doing that. I have a 45% silver solder, and it's a Silphos product, and we're going to come over here and we're going to make a wrap around this copper tube, a full 360 degree wrap with this 1/16 45% silver solder. So watch me while I make that little program around there.
Just a single turn?
Just a single turn. The trick here is to get this just enough that you don't want to fill the hole in the center with solder, but that you want to be able to get a full circumferential joint around that. So I'm just a little tight here. I'm going to put some flux on. Now in this case it's a stay silv flux. It's a paste flux, it's a white flux. There are other fluxes out there, a black flux for high heat applications. When you have to cook something for a long time, you use the black flux, which is more heat tolerant than the white flux. But I know, once again, from experience, that this is not going to be a lengthy joint. It should heat up very quickly, and we'll get that solder, that silver solder brazed on the joint. Now I also put extra flux on the joint. You can't overflux the joint. There is one thing you need to be aware of, that wherever you put the flux, the solder will flow. So silver solder will follow the flux. So you want to be just a little careful where you're applying that flux. So I'm not getting any flux down on the hex of the adapter. As you see, this hex is remaining free of solder, but free of flux, but I am making sure I fully loaded that flux on the remainder of it, because that's what does the cleaning action that you can't do any other way. And we're going to use a MAP gas in this instance, because I have a little heavier tubing. I have a much more massive adapter than I normally have, so I'm going to go ahead on the presumption that we're going to have to put just a little more heat on this program. So we're going to do that right now. Constitutes the brazing on that. You see that now I've got a smooth uniform silver band around the copper tube, Yeah, there's no evidence of that wire remaining on top of the hex, and that is white hot. So we're not going to grab that right now. We're going to come over here with my trusty stay bottle and cool that down just a little bit. Once that's cool, then we go down in the water faucet outside and cool the remainder. Here's the joint itself, no solder in the hole, and we'll check that with the drill bit as well, just to make sure that there's no problem with plugging that line. And there you are. But it goes down to this end. We're going to go ahead then and fit this compression fitting to that end, and that line will have been installed and we'll be good to go with that.
Well, thank you so much for joining us at Bob's shop today. Bob, thanks so much. Hope to see you guys right here next time on the Crow's Nest Railroad.